You guys have all typed it as binomial. Why? Because you see that there is a sample size, right? I have my n, right? Five teenagers selected at random, so this is my n, and there's no word mean or average in here anywhere, so it's binomial. Oops. I guess I can't do that one next, can I? Yes?
So at least, the wording, at least 3 would mean 3, 4, 5?
Yes, it would be.
Okay.
Also, you'll notice the binomial has this percentage in there, right? At least 3 means that we'll have, out of 5, it means, at least 3 means 3, 4, or 5. Exactly, you have to find all 3 of them and add them, because or means add. Right? So probability of 3, of at least 3 means I have 3 of them, or I have 4 of them, or I have 5 of them. So yeah, good. Nice job. How about this problem? What kind of problem is this one? Okay, I've gotten 7 answers. Getting some different stuff in here. All right, so what you have to look for is this one, you tell it because I'm just giving you the information. If I just give you a bunch of data and say, here it is, here are the numbers, here are the probabilities, you don't have to find the probabilities. This is just a basic probability distribution. Here's your data right here. What's the probability that someone has 2 cards, exactly 2 cards? Also, do you see the word normal here anywhere? The word normal is not here anywhere. No word normal at all.
0.27.
Right. The probability of having 2 cards is probability of X is 0.27. I'm just giving you the probabilities. You don't have to use normal C. You have to find them. You don't have to use that whole P of X equals NCX times little p to the X times little q to the N minus X. You don't have to use any of that to find the probabilities. I just give them to you. Here they are. Boom. There you go. When I give you all the probabilities, that is a discrete probability distribution. This is a discrete probability distribution where I'm just giving it to you and saying, here it is. And you just, it's a table. Here's and if I give you a table or give you the data to put into a table, then that's a discrete probability distribution. And all you got to do is look at the numbers, and the only thing I'm going to ask you for is the expected value or the mean, or what's the probability that, well, so the probability of the number of cards is 2 is 0.27. What's the probability of 2 or more cards? How would you find that? Of at least 2 cards. What would you do there? Probability of at least 2. How would you find that?
You find individuals and then add them up.
Yeah, so the probability of 2 is this one right here. The probability of 3 is this one right here. The probability of having 4 cards is right there. The probability of having 2 or 3 or 4 cards, you just add them up. Make sense? You just would add these probabilities. Or as you add. Would you take a look at that for a second, and then we'll go to another one. Okay. How about this one? What kind of problem is this?
You just find the problem.
Text me. Private chat me what kind of problem it is. What kind of distribution is it? Right, so I think you guys are cluing in. It's a basic, see it says normal right there? Say normal distribution. So area under the curve is the same thing as saying find the probability. Area under the curve area is the same as probability. So this is a probability problem. Find the probability that my z-scores between these two. Normal distribution, you're going to use normal CDF. Right, so it's normal, and there's no sample size. I'm not doing a sample size, so it's just straight up normal CDF of these two z-scores. Oh, we already did that one. You guys are good. Yep, so binomial has a sample size n, no mean or average. Right, and then this one again, this one would be a discrete probability distribution because again, you're just given the x's and the probabilities. It's a table. Let's find another one. What kind of problem is this? Oh, good. Yep. Let's see, people. So I'm not asking for a probability, so it's not a distribution. So it's not one of those four things we talked about because it's not a probability. This is I think most of you guys have it. It is a weighted mean problem. So this is a weighted mean problem because you have some are worth more. Here's an A. This D is worth more than the F because the D is worth 5 units and the F is only worth 1 unit. So they're weighted differently. This D has more weight than the F has. So this is a weighted mean. We'll do that one later on. How about this one? Sorry, I need to move this over here. So I'm asking for a probability. Once I ask you for a probability, then there are 4 different options you can choose. You got to pick one. Figure out which one it is. Pick the correct one. That's the trouble. That's the hard part, right? Is finding the correct one. So it is a I think people are getting this one. Some people have it. Most people have it. So people are picking up, we got a whole bunch of different options here. Okay, so read through. The easiest thing to do is to see if it says normal. And the second thing to check is to see if there's a sample size n. So those are the 2 things. So it does say normal distributed. So then you check and see, is there a sample size n? Is there a sample size n? I do not see a sample size n. So this is a basic normal one. There's no sample size. Does that make sense? Now, if you didn't see the word normal and you had a sample, then you got to check and see if you have the word mean. If you have the word mean, then it's central limit theorem. If it's not, then it's binomial. Those are kind of the ways of sorting that out. Can I find that table again? right? So we kind of go back to here, right? If it has a sample size n, then it's either binomial or central limit theorem. If it says it's normal and has a mean, then it's either basic normal or central limit theorem. So if it has both, it's central limit theorem. If it only has one or the other, if it only has, if it only says normal, then it's basic normal. If it only has a sample size n and not the mean, then it's binomial. Okay, let's jump back to where we were, which was we're here. So I want to go to, how do I get to that? Did I create this somewhere? I created this somewhere. I did. Yes, I think I did. Uh-oh. Okay, well, forget that. That's not going to happen. All right, how about this one? What kind of problem is this? Okay, people are getting it. A few more people are getting it. It is a probability distribution, but what kind? There's 4 different possibilities. Which kind is it? All right, so remember, discrete is the one where I give you the table and say, here you go, here's all the data. That's the one that is kind of its own standalone. So then you look and see, does it say normal, and is there a sample size? Sample size n. So I don't see the word normal in here anywhere. Is there a sample size n? Yes, there's a sample size of 5. Okay, so then it's either binomial or central limit theorem. Is there the word mean or average in here anywhere? Nope, no word mean or average, so it's binomial, exactly. Good job, guys. Okay, let's try this one. Find the expected number of customers. Two people have got it. Three people have got it. 4. What kind of probability distribution is it? Yes, it's a probability distribution, but which kind? There's 4 different options. Oh, I think are you guys saying this is the basic one? Okay, yeah. So yeah, it's the basic discrete probability distribution. Okay, good. And then
On the exam, are you going to ask us to like put down what kind of distribution or
no.
process?
However, if you don't know what kind, you will do what some people do, which they do the wrong thing completely, and they get 0 points on it. Right? So identifying what kind of problem it is paramount to succeeding in this exam, because if you can't, well guys, here's a new one, take a look at this one. If you can't figure that out, then it's going to cause all kinds of problems, and you'll be doing weird random things. and you'll be working hard for no particular reason. Okay, remember the two questions you should ask yourself. Well, first of all, say, is this a table where they've just given me stuff? And if not, then you ask yourself two questions. One, is there a sample size n? And two, is it normally distributed? Do you have the word mean? Is it normally distributed with a mean? So there is a sample size n, sample of 14 camels. So it means it's either going to be the binomial or it's going to be central limit theorem. Does it have the word mean or average? Yep, here's the word mean. This is central limit theorem. It has a mean and it has a sample size, sample of 14. So write down how to find these, right? It's really important to kind of practice these ones a bit. Okay, so let's go ahead and go through some more stuff, just some basics. So these are the kind of problems I might ask you, right? Find the expected value, or what's the expectation, or expected number of blah, blah, blah. Remember, expected value, E of x is just mean. It's just mu. It's your mean. They're the same thing. Exactly the same thing. So if it's binomial, then the expected value is the same thing as the mean, just NP. Right? Remember that one? Binomial mean is NP. Standard deviation is square root of NPQ. That should be in your notes somewhere. If it's not binomial, if we have this, then try making a probability table, right? And then the expected value is every x value. It's a weighted mean, right? This is basically a weighted mean. It's every x value multiplied by its probability, its weight, and then you're going to add all those up. And you divide by the sum of the weights, but the sum of the probabilities is always going to equal 1 or 100%, so that you don't even have to divide. It's just every x value multiplied by its probability, and then you add them all up. Binomials, you should be looking for n number of trials, right? And again, it doesn't say mean on there anywhere, or I should rephrase that. It doesn't give you a mean. I might ask you for the mean, right? Because here's the mean right here. You can find the mean, but I won't give you the mean. I expect you to tell me what the mean is. You'll have an n, and you will not be given the mean. And then here are some things. N is the number of trials. Little p is the probability of success for one tiny trial. Q is the probability of failure for that one tiny trial. And remember that 1 minus p is q, because these two, p and q, are complements, right? They have to add up to 1 or 100%. So if you have p, you can find q by taking 1 and subtracting p. The expected value is NP, variance is NPQ, and the standard deviation is the square root of NPQ, the square root of variance, the square root of NPQ. And then this is what you're trying to find. So let me see if I can get to that slide, actually. That would be useful. So if you kind of look through this, the things that I might ask you for in this, you're going to be given N and P and Q. I might ask you in binomial, I might ask you what the expected value of something is, the probability of something is, down here, or the standard deviation of something. So the things I will ask you for would be the mean, right, the mean or expected value, the standard deviation, or the probability of getting a particular x. And that's when you have this big, long formula. Remember that x is the only thing that varies. X is my variable, so that this changes. The other things stay constant. The n, the p, and the little p and the little q stay constant. But the big P, the probability that I'm asking you to find, is this formula here. And depends upon what x is. Questions? Yes. That is the, wait. I don't have any, no, that's not a question. Sorry. Okay. So binomial probabilities, I could ask you for just the probability itself, or I can ask you something like this. Probability that x is less than 4. Less than 4 means you have to add up. Less than 4 means 3, 2, 1, or 0. Don't forget 0. 0 is the hero. You can always have 0 successes. And it's or. 3 or 4, or, 3 or 2, or 1 or 0. So ors you add. You add the probabilities. I also might ask you to find the probability of at least 1. And remember, the probability of at least 1 is 1 minus the probability of none, 1 minus the probability of 0. Because say I have eight possible attempts. I could have 0, 1, 2, 3, 4, 5, 6, 7, or 8 successes. At least 1 means all these ones here are circled in red. If I'm trying to find the probability of all of these, I can either find all 8 of them and add them up, or I can just find the probability of 0 and subtract from 1, because all of them all together, the purple and the red all together, have to add up to 1 or 100%. So that's part of that probability rule that's so useful. Also, let's take a look at what these phrases mean, making sure you guys are good with that. So at least 3, less than 3, more than 3, no more than 3. What do those mean? Maybe I'll just cover this up for a second. At least 3, less than 3, no more than 3, more than 3, what does that mean? So everybody take a second and think about that. Take a minute and think about it. Half a minute. And what numbers? So we're doing, say we're doing, we have all these numbers here. We're doing it 8 times. What does at least 3 mean? What does less than 3 mean? What does more than 3 mean?
Professor, so for the probability of at least 1, that only applies to 1, when it's like 1 minus probability of 0.
Yeah.
When we do the probability, or 1 minus probability of 0.
I'm sorry, what's the question again?
So when do we apply the 1 minus the probability of 0?
When it's at least 1.
Okay, so just for 1.
Yeah. If it was at least 2, right, then we would have to find the probability of 0 and 1 and subtract those from 1 to get 2 or more. Does that kind of make sense?
So if it was at least, yeah, I think I understand.
All right, so at least 3 means 3, 4, 5, 6, and so on up, right? Less than 3 is 0, 1, and 2. More than 3 is 4, 5, 6, 7, and so on. No more than 3, you can think of it as not more than 3. Not more than 3 means you are not more than 3. You can be 3, that's not more than 3, or anything below it is not more than 3. This one I may not do necessarily, but these first ones in here, there's a good chance one of them will be on the exam. Less than 3 is more than 3 is, yeah, that seems good. Great. Okay. Oh, whoops. So let's have you guys do a problem. So I'm going to give you guys 10 minutes. I'll put you guys into groups. And so I would say do A, B, and D first. Right? So do A, B, D, and then go back and catch C. Do these ones first. Do C last.